In this video, we will be learning about the probability of multiple events. We will do the probability of event A and event B, and we will do the probability of event A or event B. So starting with the probability of event A and event B, first we need to define dependent events and independent events. When the occurrence of one event affects how a second event can occur, the events are dependent events. Otherwise, the events are independent events. So let's take a look at some examples. We're going to classify each pair of events as dependent or independent. Part A. A member of the junior class is selected. One of her pets is selected. So think about whether the second event depends on the results of the first event. And it would depend on the results of the first event because it depends which member of the junior class is selected when you select one of her pets. So these are dependent events. Part B. A member of the junior class is selected as junior class president. A freshman is selected as freshman class president. These are independent events because they're separate groups. So it doesn't matter which junior is chosen when you choose the freshman. Part C. An odd-numbered problem is assigned for homework. An even-numbered problem is picked for a test. What do you think? Again, these are independent because they're different sets of problems. So it doesn't matter which odd numbers you choose, you still have the same even number problems to pick from for the second event. And the last one, the sum of two rolls on a number cube is 6. The product of the same two rolls is 8. In this example, let's think about the possible outcomes. If the sum of two rolls on a number cube is 6, and number cubes are dice, if we roll 2 dice, we could get a 1 and a 5. That would have a sum of 6. We could get a 2 and a 4. That would have a sum of 6. Or we could get a 3 and a 3. Those are all the ways to get a sum of a 6. Now it depends which one of those we get for the product to be 8, because 1 times 5 is not 8, it's 5. 2 times 4 is 8. And 3 times 3 is not 8, it's 9. So these are definitely dependent events. Now we're going to find the probability that two independent events will both occur. If A and B are independent events, then the probability of A and B is the probability of A times the probability of B. Looking at this first example, Q and R are independent events. Find the probability of Q and R, given the probability of Q and the probability of R. So the probability of Q and R will be, we just multiply those probabilities together. 1 over 8 times 2 over 5. And remember, when we multiply fractions, we do the top times the top, the bottom times the bottom. We can also simplify ahead of time. The 2 and the 8 can both be divided by 2, so that becomes a 1 and a 4, giving us top times top, 1, bottom times bottom, 20, 1 over 20. In the next example, the probability of Q and R will be 0.8 times 0.2. And when we multiply decimals, we multiply those numbers together. So 8 times 2 is 16. And I have 2 digits to the right of a decimal place, so I move my decimal 2 places to the left and get 0.16. Okay. Now a problem in context. Suppose you have 7 CDs in a box. 4 are rock, 1 is jazz, and 2 are country. Today you choose one CD without looking, play it, and put it back in the box. Tomorrow you do the same thing. What is the probability that you choose a country CD both days? Okay, so we have 7 total, 4 rock, 1 jazz, 2 country. We want the probability that you choose country 2 days in a row. Well, the first day, the probability of choosing country is 2 out of 7. And then it's key to pay attention to whether or not the item is replaced. And it does say that you put it back in the box. So the second day, you have the same set of CDs to choose from. So the probability of choosing country the second day is again going to be 2 over 7. We multiply those probabilities together and we get 4 over 49. You have a drawer with 5 pairs of white socks, 3 pairs of black socks, and 1 pair of red socks. You choose 1 pair of socks at random each morning starting on Monday. You do not put the socks you choose back in the drawer. That's an important part of this problem. You do not put the socks you choose back in the drawer. Okay, so we've got 5 white socks, 3 black, and 1 red, which makes a total of 9. And in part A, we want the probability that you select black socks on Monday and white socks on Tuesday. The probability of selecting black socks on Monday will be 3 out of 9. Now, remember that you wore black socks on Monday and you didn't put them back in your drawer. The probability of choosing white socks on Tuesday, well, you still have 5 pairs of white socks in your drawer, but the total number of pairs of socks has been reduced to 8 because that 1 pair that you wore on Monday is not in the drawer anymore. So our sample space will only have 8 pairs of socks on the second day. And now we multiply. I'm going to reduce ahead of time again because that makes it easier to not have to reduce at the end. 3 over 9 reduces to 1 over 3. And top times top is 5, bottom times bottom, 24. The probability that you select white socks on Monday and Tuesday. The probability of white socks on Monday is going to be 5 out of 9. But on the second day, you've already worn a pair of white socks and you didn't put them back in the drawer, which means you only have 4 pairs of white socks left in the drawer for Tuesday. And your total number of pairs of socks has been reduced to 8. So now we multiply. 4 over 8 can be reduced to 1/2. And we do top times top, 5, bottom times bottom, 18. Now we're going to find the probability of event A or event B. And first we need to define mutually exclusive events. 2 events that cannot happen at the same time are mutually exclusive events. If A and B are mutually exclusive events, then the probability of event A and B is 0. So if one happens, the other cannot, and vice versa. To find the probability of event A or event B occurring, you need to determine whether events A and B are mutually exclusive. So let's talk about mutually exclusive events and decide if these events are mutually exclusive or not. In number 5, it says you randomly select an integer from 1 to 100. State whether the events are mutually exclusive. A. The integer is less than 40. The integer is greater than 50. These events are mutually exclusive. If you select an integer that's less than 40, it's not going to also be greater than 50. And if you select an integer that's greater than 50, it will not be less than 40. So those events can't occur at the same time. Part B. The integer is odd. The integer is a multiple of 4. This is another example of mutually exclusive events. If you choose an odd integer, it's not going to be a multiple of 4 because all multiples of 4 are even. C, the integer is less than 50, the integer is greater than 40. These two events can occur simultaneously. For example, if you pick the number 45, it's less than 50 and it's greater than 40. So these events are not mutually exclusive. Okay, so now we're going to do an example where we actually find the probability of event A or event B. Exactly 62% of the students in your school are under 17 years old. In addition, 4% of the students are over 18. What is the probability that a student chosen at random is under 17 or over 18? First, we need to determine if the events are mutually exclusive or not. And since if you choose somebody who's under 17, they're not also going to be over 18. These events are mutually exclusive. And when two events are mutually exclusive, if you look up at the top, the probability of event A or B is just going to be the probability of event A plus the probability of event B. So the probability of a student being under 8 or under 17 or over 18 is going to be the probability that a student is under 17 plus the probability that a student is over 18. The probability that a student is under 17 is 62%. The probability that a student is over 18 is 4%. So I add those together and I get 66%. Okay, now we're going to look at some examples where you roll a number cube or dice. In part A, we want the probability of rolling an even or a 3. So if we look at our options, I have 1, 2, 3 even numbers. So, and then I have 1, 3. And those events are mutually exclusive because if I roll a 3, it's not even. And if I roll an even, it's not a 3. So first we note that they are mutually exclusive events. And since they are, we just do the probability of A plus the probability of B. So the probability of an even plus the probability of a 3. And the probability of an even is 3 out of 6. The probability of rolling a 3 is 1 out of 6. We add those together, we add the numerators, keep the denominator the same, 4 out of 6, which reduces to 2/3. In the next one, the probability of getting less than 4 or even, well, the numbers that are less than 4 would include 1, 2, and 3, and the evens are 2, 4, and 6. So the 2 is a place where those sample spaces overlap. So these are not mutually exclusive. And since these events are not mutually exclusive, we do the probability of event A plus the probability of event B minus the probability of event A and B. So the probability of getting less than 4 plus the probability of getting an even minus the probability of getting less than 4 and even. The probability of getting less than 4 is 3 out of 6. The probability of an even is also 3 out of 6. The probability of getting both less than 4 and even on the same roll is 1 out of 6. And we're referring to that one case where it's both less than 4 and even. And so combining these fractions, add the tops, 3 plus 3, and then minus 1 gives us 5 out of 6. So basically what we do is we subtract the probability that both occur because that 2 was counted twice. It was counted in the less than 4 and the even, and then we subtract it to make it only counted once. Okay, one more example. The probability of prime or odd. It's important to note that 1 is not prime. So our prime numbers don't include 1, and they are numbers who are only divisible by themselves and 1. So the prime numbers in this set are 2, 3, and 5. The odd numbers are 1, 3, and 5. So we had two numbers that were both prime and odd, which makes these events not mutually exclusive again. So I'm going to do the probability of a prime plus the probability of an odd minus the probability of both prime and odd. The probability of a prime number was 3 out of 6. The probability of an odd number was also 3 out of 6. And then the probability of prime and odd, well, there were two cases that were both prime and odd, so I subtract those two cases because they were counted twice. And that gives us 4 out of 6, or 2/3. If you draw one card from a standard 52 card deck, find each probability. What is the probability that you draw a king or an ace? Well, I have 4 kings and I have 4 aces, and there's no overlap in those sets, so these events are mutually exclusive. So I just do the probability of getting an ace plus the probability of drawing a king. The probability of an ace is 4 out of 52. Probability of a king is also 4 out of 52. Add those together, we get 8 out of 52, which reduces to 2 out of 13. And one last example, what's the probability that you draw a king or a heart? My kings, I have 4 of those. And then I have 13 hearts, this row right here. And there is an overlapping card. The king of hearts satisfies both of those requirements. It's a place that these sets overlap. So they're not mutually exclusive events. And I'm going to do the probability of a king plus the probability of a heart minus the probability of a king and a heart. The probability of a king is 4 out of 52 plus the probability of a heart, which is 13 out of 52. And then there's one card that was both a king and a heart, so I subtract 1 out of 52, and that gives us 16 out of 52, or 4 over 13.